So today I figured we would take a look at creating a boat in Unreal using the dynamic water physics plugin on the Unreal Marketplace. So here I have a completely empty project built with 4.26. So to begin with, let's install the dynamic water physics plugin so that we can use it with this project. If you have already purchased it, you can simply install it to your engine. If you just want to try out the plugin without making a purchase, you can use the trial version, which you can find here on the Marketplace description page. So let's install the trial version just to show how that would work. So let's choose the newest version, download that. Let's place it in our downloads directory. And let's take this, extract it. Now you will need to take this directory and move it into the plugins directory for your project directory. So let's create a plugins directory. And let's move this directory that we just unzipped in here. This can be named anything, doesn't really matter, but I'm gonna remove all of this junk in the end, like so. And there we go. You should have the plugin installed. So let's open that up. So the first thing we want to do is to add some water, and one of the big selling points of Unreal Engine 4.26 was the inclusion of the new water system. So let's leverage that. It should fit nicely. So we should be able, let's just search for it, water on all the built-in ones. So we need to enable the water plugin. Future me chiming in to say that past me forgot to mention that if you install the plugin into the engine, you will of course need to enable that plugin here as well. And that requires us to restart the editor. So now that we've enabled the water plugin, let's set up our scene such that we have some water. Let's just remove the default cube. I don't need the reflection capture. Let's add a landscape. Since the new water system requires you to have a landscape, let's just fill the world, and do not forget to enable the edit layers, otherwise the water will not work. Let's create that. I see why it was slow. About 4,000 shaders. I will probably need to fast forward while that is happening. There we go. All nice and compiled. So now that we have our landscape and our very compiled shaders, we can exit out of landscape mode and we can add an ocean. So let's just search for ocean. Since we've enabled the plugin, it will just appear up here. Let's place it. And we have more shaders to compile. Okay, here we go. Wow, that's some beautiful water. This does not look correct. Is this correct? Maybe if you just, there we go. If you just move it a bit, it snaps into place. Okay, so I'm just gonna turn off the static lighting for this scene since I don't want to deal with this message. That's of course optional. And let's save this level. Let's call it our boat level. Now, as for water physics, that is fairly simple to add. If you have the plugin installed, we should be able to search for water body. And we can see down here that there is an actor called water physics UE4 water body. So we can just drag and drop that into our scene. So this is the layer in between the Unreal water system and the custom made water physics system that this plugin provides. So the way you use this is that you go down here into the details and you add a new water body, and you can pick whichever object you want to include in your scene. And for us, we just want the ocean. I am going to go ahead and disable velocity because by default Unreal's velocity for an ocean is just a circle around the ocean. So it always follows the tangent of the spline, which is very odd. That should be about it for adding physics to this ocean. We can just go ahead and test this by dragging out an object, and let's enable physics. And we also need to enable overlap events for it to overlap with the ocean so that the ocean can actually detect that there's an object. I'm gonna make it bigger just so we can see it. Let's simulate. And look at that. It's floating. And it's interacting with the waves. Very accurate. That's all well and good, but we wanted to make a boat. So let's go ahead and do that. There's a few ways you could get a boat mesh. Obviously go online, you might have your own. I'm just gonna use one of my own. You can find this one in the description if you want to download that, but you can use your own. There's no steps in this tutorial that really requires you to use this particular boat. So I'm just gonna create a new folder here called boat. I'm gonna drag and drop this in here. Just do default settings, that should be fine. And now we have a dinghy. Let's save all that. So here's our little boat. Looks good. It also comes shipped with some simple collision. You could just generate your own if you wanted to. Doesn't have to be accurate. Just have to vaguely describe the shape of the boat. We can try this out by just dragging the boat out and doing the same thing that we did with the cube. Enable the overlap events and the physics. And simulate again. Look at that. A boat floating on the water. It's very bouncy, and that's probably due to the very large waves. Probably gonna have to tweak those a little bit. So let's go ahead and do that immediately. Let us change the amplitude to something more manageable. Does this look good? It does, but we do get some really funky looking waves. I think we will need to change the wavelength to something smaller. This looks pretty good. The amplitude is still a little bit high, I think. So let's drop that down a little bit. That's looking better. We can keep going down with the wavelength. Still getting some of that black stuff. It's not looking all that fun. This is looking better. Hopefully we can adjust that a little bit. That's looking really good. I'm liking this. The waves, of course, up to you. Mostly just for taste. I'm thinking this looking about right size for this size of boat. I wouldn't want to be on a boat on an ocean with larger waves than this. I'd get really seasick. So let's try this. Let's just look at it. Oh, it's looking good. It's floating. It's looking really nice. But you probably want to be able to drive the boat. So let's do that. Let's create some control system for the boat. So I'm gonna create a new blueprint. It's gonna make a pawn so we can control it. Let's call it BP boat. Let's open you up. Okay, looking good. Let's add a static mesh to this pawn and make it into our dinghy. That's looking good. And turn on physics and make sure generate overlaps is enabled, which it is. Now we can replace you with our own new boat. Let's simulate and look at that. So first of all, we're probably gonna need a way of possessing the boat. And right now, if we do this by just forcing Unreal to possess the boat at launch or at play, it's not gonna look great. Oh, it's looking actually pretty cool, but I'd like to turn my camera around a little bit and get a better view. So I'm just gonna add a new camera component and a spring arm to attach the camera on. Let's put you on the spring arm and extend this spring arm just a little bit, perhaps 700. Looking good. And let's make the rotation world so we don't get seasick. And let's just, oh, I cannot, okay. Let's rotate this up just a little bit. Play again. That's looking way better. Now I can see my boat. However, I cannot control the camera, so I'm just gonna add some real simple camera movements here. Let's go for input event mouse X. There we go, and we'll do the same for Y. So when I drag my camera around the x-axis, I will want to add world rotation offset. I suppose is the axis value times some delta, so that we're not dependent on frame rate. And we will wanna do it around the yaw axis, around the Z. Let's look at how that looks. That's probably gonna be too slow, so let's just put in some random number here. See how that turns out. Oh, this looks pretty good. I think for now this might actually be enough. Like, we don't need to do the y-axis. It's much more complicated than just adding yaw. You will need to rotate around the right vector of the camera. So let's just hold off on that one and make the boat dry first, which we'd want to do. Like right now, it's not super exciting. Just looking at the boat floating in the water. It's pretty cool, but ideally I want it to move. So I am going to make it move. And since it is a physically simulated object, the most appropriate way to make it move is to add a force. Of course, you could do set actor location and things like that, but then you lose the whole appeal of having a physically simulated actor. So I will just read the input. Perhaps we can create an input axis actually for this. Let's do that since it's gonna be nicer code-wise. And we can call this throttle. And it's gonna be W and S is gonna be backwards. And while we're at this, we can add an axis for our rudder control, which we're probably gonna be adding at a later point anyway. So let's just do rudder control. And that's gonna be A and D. Let's see, one of these are gonna be -1. I'm always picked the wrong one. So let's see here. Input axis throttle. We can take our mesh and we can do add a force. And we probably want to add it at the forward direction of the boat. So let's get forward vector. You can check the forward vector by just pressing the object with the object mode selected. As in a local transform, so when you rotate it, the axis follows the object and not the world. And you can see that X is forward. Some meshes might have Y forward or Z forward depending on the setup. It's pretty common to have Y forward if you're working with Maya, for example. So let's multiply this with some force constant. I am also going to get the mass of this object. That way the amount of force will be constant even if the mass changes. It will also make this value way smaller due to Unreal using centimeters instead of meters. The force values has a tendency to really balloon to insane sizes. So it can be a good idea to multiply with mass to kind of reduce those sizes just a little bit. I'm also gonna plug this in, and there's no need to multiply with delta time since that is handled by the physics engine. As long as you just add one force per frame, you should be good. Well, not one force, but this particular force, one is per frame. Let's test this out. Press W, see what's happening. Oh my god, it's going. Oh, whoa. Whoa, it's very fast. Wow. Okay, I'm just gonna go ahead and tweak that a little bit. Let's half of that perhaps. Still pretty fast. I'm just gonna go 200. I don't know. My dinghies are usually not that fast when I've been rowing them in the past. Perhaps you guys are better rowers than me. But they still seems a little bit fast, but hey, it's a bit fun. I'm liking this. That should be good. So just making the boat go forward not super exciting. You probably want to be able to turn the boat. So let's add a rudder, or some way of controlling direction. So there's a few ways you could do that. One way is just change the direction of the force. The other way is add an actual rudder. So there's supposed to be a rudder mesh here, but can't be arsed importing that one separately. So I'm just gonna add a separate collider here, which is gonna represent a rudder, and then we're gonna turn that collider to make the boat turn. And there's actually a super good way of doing this, really convenient, that makes it way more performant since you're not adding unnecessary colliders, and that is to use a water physics collision component. So the water physics collision component is like a virtual collider, which is only picked up by the water system and not by the Unreal collision system. So it's a great way of kind of adding logical floaty bits to your boat, or control parts that are supposed to simulate the behavior of a real component on the boat, like a rudder or like a keel on a big ship. So we're gonna place this back here where you would expect to see a rudder, and we're gonna select box mode. Since I'd say most rudders are pretty square, I'm gonna reshape this so it looks a little bit more like a rudder. Something like this. It can be a little bit bigger than, you know, a realistic rudder. The size doesn't matter too much. I'm mostly just doing it for visual effect, and it should be slimmer so that, you know, it has minimal drag on the front and maximum amount of drag on the sides. And now we can go in here and we can do input, axis, rudder control, and we can take our rudder. Let's rename this actually. Let's call it rudder collision. And we will set the relative rotation. Let's see here. What do we want the rotation to be? We want it to be something like negative 40, 45. 45 degrees seems pretty good. So that's around the z-axis or yaw. So we're probably gonna want to lerp in between negative 45 and 45, depending on this axis right here. So that should be it. Just to make this a little bit easier to see, I'm gonna go ahead and add a some form of visualization to this so that I can see what's going on. Let's enable engine content and let's add a cube. Move you back here. Obviously this could be like an actual mesh of a rudder if you had one for your boat. It's in general a pretty good idea to kind of detach the physical aspects of the boat from the logical ones, because then you get a lot more control over the behavior of the boat. But it's not strictly necessary. The good thing about keeping your boat more in line with the mesh is that you will get a more realistic boat. The more realistic the boat is in shape, the more realistically it's gonna behave in the water. So let's play this, and oh, something is going on over here. I think it is the collision that is causing issues. So let's disable this. Yes, that was it. So obviously something is not right here. Ah, you see here, here's the problem. This one goes from -1 to 1. We want something goes between 0 and 1. So we're gonna have to add 1 and divide by 0, divide by 2. It's a simple remap of -1 to 1 to 0 to 1. Let's plug you in, and then let's see here. There we go. So if I start driving now, I can control the boat by turning the rudder. So that's it. That's basically how you make a boat. It's not more complicated than this. Of course, if you want more complicated controls, you can add that. You can make the rudder more complicated. You can make the engine more complicated. If you wanted a sail, you could simulate the forces of a sail. If you have any questions, feel free to shoot me an email. If you like to see any other kind of tutorial or an explanation of a system within the plugin, then I'm always willing to explore that. So thank you for watching, and I'll see you next time.